Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this will be the first video for Assalamualaikum warahmatullahi wabarakatuh. So today is your first lecture for EECE 7327 Micro Electromechanical Sensors, Actuators and System. So I'll give you a short briefing for this subject. So what we're going to go through is the outline, starting from learning outcome and what is actually MEMS and so on. So for your learning outcome for today, the objective of this course is for you to study the fundamental of MEMS, and then we are going to focus on the scaling issues, and you're going to learn the detail on how to fabricate MEMS device, how we're going to characterize the MEMS device, and some of the applications. So here is the assessment for your course EECE 7327. So you're going to have what we have problems or reading summary. So I'm going to give you some articles every week. So what you need to do is you need to go through the articles and read it and provide a short summary of what you understand from that articles. And on top of that, there will be some video for the lecture, and then you have here what we call a project. So I hope by now you already installed the consoles, and what you need to do is you are going to have one paper on your topic. So you can have any MEMS device such as piezoelectric, electrostatics. So we'll go through one by one later. So you are going to choose one of the device and then simulate the device and have the result and the final report. So this report will be in terms of a format of a paper. On top of that, you have a short midterm test and then following with the final exam 50%. So means here your carry marks is around 50% and your final will be 50%. Regarding the reading summary, so what you need to do here is I will give you some of the paper like what have you done past 2 weeks. So what you need to do is you need to give a brief summary according to the topic. So at first you will watch the video on the theory, and then on top of that you will be given a 2 technical paper and try to summarize what have you understand best and what you don't understand. Relate the summary with on top of the figures and all equation related according to the video of the theory. For the project that consists of 20%. So this project is about console. So I know you already installed the console. So what you need to do is you need to choose one of the MEMS device such as microfluidic or MEMS piezoelectric or any device that you want to choose according to the theory that we will cover in this syllabus. And what you need to do is you need to simulate the device in console multiphysics and provide the results, all the results and the theory at the background, where you're going to provide a 3-page report consists of the theory, simulation, methodology, results and discussion. And the template of the report will be in terms of IEEE format. Regarding on the textbook, so you have several reference books. So the one that we are going to refer the most is from Thomas Adams Springer book. So the title is Introductory MEMS Fabrication and Applications. So this is the book that we are going to refer the most. You can find this book online, so let me know if you can't find it. And on top of that, there is some supplementary books, so you can refer this highlight one, Foundation of MEMS by Chang Liu, and also the Fundamental of Fabrication and Mark Mado, and also Microsystem Design by Stephen Centuria. But what we're going to refer the most is the Adam books here. So let's go through back what have you summarized in the 1-page summary last week. So what is actually MEMS? So as we go to the definition, micro is a micro electromechanical system. So we're talking about micro. Micro means 10 power of -6, so it's very small. Electro means some of the component of MEMS having electrical components. It also have mechanical components, so it's a combination. So this subject is a multidisciplinary where you're going to learn some about electrical part, and some of its mechanical parts such as trace, thread, strain, and the others. Okay, and all these are in the system. So it is a small system. There is a micron, but it consists of electrical and mechanical. So this component will form a system. Okay, so this is the examples of MEMS device that you can find around. The first one is from your airbag from your car. So inside the airbag system, there is a MEMS device inside. We have accelerometer inside, and also inside your computer printer, the inkjet printhead is also a MEMS device. And of course, inside your cell phone, there is a lot of MEMS device there to have the radio frequency device. And as we know recently, this is a latest innovation where it is a lab on chip. Means if you know the recent news here, if there is COVID, right? So we need to send the sample of the for the COVID test to the lab. So when we want to send to the lab, it needs some time, right? Because there is some expertise to check, to analyze the sample. So what MEMS can help here is to have what we call lab on chip. Means inside your chip, you can automatically test whether you are positive or negative there. So it can be remotely done. Okay, and we have also micro mirrors, and a lot of devices around you consist of MEMS device. So this shows that MEMS device is very important in our life. Okay, so just now is what is MEMS. So now we go why we need to go to the micro size. Is it critical? So as we know, when we have a smaller device, it requires less source, right? So when it's less source, it will lead to less energy, less power to activate the MEMS device. So it will lead to low cost. Okay. On top of that, MEMS device is integrated with what we call CMOS. I believe we have heard about what we call what we call CMOS. What is CMOS actually? It is a complementary metal oxide semiconductor device. So it's inside your chip. Means that whatever you have inside your computer, there is the integrated circuit. Let's say the Intel chip there. So it is consists of CMOS, complementary metal oxide semiconductor, in both digital and analog. So as we know, the CMOS device, they run it using the batch fabrication. So it's in a clean room. So means, let's say this is semiconductor, right? So we have a wafer here. So on top of here, there is a lot of chips. So all this is run in the batch fabrication inside the clean room. So since your MEMS device is very small, and it also integrated with the electronic such as CMOS circuits, so we can also run your MEMS device using the batch fabrication process. Why we need this batch? Because it will lead to low cost. Means at one run we can have like thousand of chips inside one wafer. Okay. So on top of that, what else is the reason why you need to make micro size? Because you know micro size is minimally invasive, so it can be disposable. Because the cost just now is cheap, right? Because it is a batch process, and it's also relate to the inexpensive low cost device, so you can dispose it. So the recent technology where they just make the MEMS device from the what we call printable MEMS device. So you actually can print your device on your plastic or polymer paper, and this device can work as what you send to the analytical lab. So the performance is almost the same. So you are going, because the cost is very cheap, so it can be easily disposable. So and on top of that, many physical fundamentals also are favored to the small scale. So we learn in next video what is the effect of the scaling law, why you need to go small because of the scaling law itself. Okay, so these are the example of the MEMS device inside your phone, any phone. So you have what we call accelerometer. This is the gyroscope to change the direction, pressure sensor for your hand, right? And you have the micro display, all the proximity sensor. You have the CMOS image sensor, and also the micrometer. mirror. So in order for the signal to wireless communication to work, so you need what we call the RF device. So we have here buck acoustic wave filter, variable capacitor, and oscillator. All of these are MEMS device. Let's say this is instrumental, so we're dealing with the mechanical component here. So we have a lot of MEMS device inside our phone. Okay. So how the MEMS industry works? So in the worldwide, so we have what we call Texas, just nearby our university at the Hulu Kelang. So we also have ST fabricate all the ICs. We have Stencil Terra at Kulim, so they have a big clean room there to fabricate the MEMS device. And also MEMS is a government company. And we have one at Sarawak, I think, for XFAB, and also they have a very big clean room for MEMS device. On top of that, this is for automotive, and also we have Avago. For RF device, mostly is from Murata, so they fabricate the buck acoustic wave filter and resonator for your RF communication. There will be the end of chapter 1. So that's what will answer you what is MEMS device, why we need MEMS device, why we need to go small, and what is some of the application of the MEMS device. So in the next video, we will learn how the scaling law will affect the performance of